Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Firstly, I'd like to thank to all people that involved in this event, in this the third Borobudur International Symposium. And then let me to introduce myself. My name is Adi Ihsan Imami. I come to present my article that it is the title is Student Error in the Geometrics Van Hill's Level of Thinking. Okay, my affiliation is Universitas Singapura Bangsa Karawang, and I'm from Department Mathematics Education. And the second author is my partner, name is Nurul Wafa. The affiliation, it's same with me, it's in the Universitas Singapura Bangsa Karawang, in the Department of Mathematics Education. Okay, let's start the presentation. The first preliminary in this research, it's part of it's a three section. The first is ideal condition, and the second is factual condition, and the third is a purpose. In the ideal condition, geometry is a mathematical object that must be mastered by students to gain confidence in their mathematical abilities and become good problem solver, and they can communicate and reason mathematically. It's all in the reference in Permendiknas 2006, and in the research Rofi Sunardi and Ivan in the 2018. I'm sorry, that's Permendiknas 2006. And then the research conducted by Van Hiele had conclusion regarding the stage of children's cognitive development in understanding geometry. There are three levels of thinking, namely the visualization level, the analytic level, and the informal deductive level. Without going through a lower level, students can advance to a higher level. It refers to Xiu Lam's in the year 2015, and the research by Heviger and Vodskova in the year of 2015. And then after the ideal condition in this research, I like to present a factual condition. A factual condition in the real life. That's in fact, most students find it difficult to learn mathematics, especially this relates to geometry. Most students are still at the stage of analytical thinking, and only a few students can reach the stage of informal deductive thinking. It referred to Diantari 2020, Ravianti 2016, and Sahara in 2021. Okay, and then the third preliminary, it's a purpose condition. The purpose of the research, the purpose of the research to determine the types of error made by students and the achievement of geometric understandings of students of is a junior high school. There's some place in city that's called Klaten. It's solving mathematical problems on the quadrilateral material based on Van Hiele theory. Okay. After the preliminary in this research, we come to methodology. Okay. In this methodological research, the first is approach and method. In this research, method and approach, I use qualitative and descriptive research, and then the subjects of this research is students from a 7th class in a junior high school in Kabupaten Klaten, and then determination of subjects. I use a technique called purposive sampling technique, and then the instrument of the test. I use the test of level of development of geometry thinking according to Van Hille's theory. And then data collection techniques. The technique is with test, non-test, and documentation. And then data analysis techniques, I refer to Sugiono in the year of 2018. It's 3 parts. The first one is reduction, data reduction, and then the second one is to display data, and the third one is to make some conclusion on it. Okay, I think it's enough for the methodology. After the methodology, we come to results and discussion. Result on this and discussion on this research. Firstly, I make some diagram chart. It's called Van Hille level. It's a level Van Hille in the class that I make this research. Okay, we can see in the diagram pie, it's with 3 part. That's first visualization level, or it's level 0, and then analysis level. The next level is level 1, and then informal deduction level 2. So the results of the percentage of geometric thinking level on SMPN Juwiring, it was obtained that students in the low level or 0 level or visualization level, they're almost 63%, and then the moderate level or level 1 or analysis level is 26%. And then higher level is level 2. This deduction informal is 11%. Okay, in the result I use there's in my instrument is I make some question that student have to answer. There's some question is based on the property of a trapezoid and a parallelogram. Is a parallelogram a trapezoid? If it is, explain. Okay, we can see the answer of the student. It's only say they say tidak termasuk or that's not a part of a parallelogram. Okay, I mean the explain is based on the result of the subject answer. It can be seen that the subject doesn't need a level 2 of Van Hille's theory. That level 2 is informal deductive level. Yes, so this subject is is not yet in the level of informal deductive. It happened because the subjects answer with a less precise statements. That the parallelogram is not a trapezoid with parallel side. It shows that the subject doesn't know the property of parallelogram and trapezoid. Thus, the subjects made a conceptual error, namely not analyzing the relationship between the quadrilateral. The next discussion is I found that the type of error made mainly by the subject is a quadrilateral concept error, a lack of skill in using geometry in solving mathematical problem relates to quadrilateral material. For example, most students don't know the property of a quadrilateral. It is also shown in the research result by Kusniati 2011 and the research that made Sunari and Yodiarto 2050 and the research that Adira Siwi and Warmi 2008. Okay, the end of the part is a conclusion. In the conclusion, I found that the result of this study indicate that 63% of students there are on the visualization level or a level 0. And then 26% of students are in the moderate analysis level or level 1. And 11% are in the informal deduction level or a level 2. Almost the students are having an error in conceptual understanding geometry. The implication for the teacher is that the teacher can find out the error faced by students in the geometry fun hill level thinking, so that they can plan better learning activities on the material to avoid the same obstacle. Okay, it's I think enough in this presentation. I'm sorry for the mistake that I've made. And then billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. Thank you all.